How's it going, everybody? It's James here again from Flocode.dev. In this video, we're going to talk about the learning path at Flocode, our courses, plans and curriculum, and we'll also cover a comprehensive roadmap for learning Python as an engineer. So welcome back to the final video of the Intro to Python series. I thank you very much for being here with me, so let's get on with it. So as we conclude this introductory course to the Flocode curriculum, let's briefly recap some of the key points that we've covered so far. We took a look at how Python has become an integral part of the engineering landscape, from basic calculations to complex data analysis and automation. We explored fundamental programming principles, paving the way for advanced study and application of Python in engineering tasks, which we will look at down the line. The freedom in design of programming is vast, and thinking programmatically, it's a new paradigm and it's a skill that has no real finish line. We're going to build on this momentum throughout the Flocode courses to allow you to pursue your own personal areas of interest. We also discussed Flocode's plan to build a vibrant community of engineers, learning and progressing together, because we might as well have a good time along the way. Now let's talk about the Python for Engineering roadmap. The roadmap's based on a Flocode newsletter article that I wrote a few months ago. The link's below in the description. You can check it out for a much more detailed overview of this topic. This summarized version is my own suggested sequential curriculum, and it's based on my personal preferences and experience, but there's no hard and fast rule for this. You just need to put on your goggles and dive in. So start with an introduction to Python, installation, setup, and then basic syntax and command line operations. Then you'll move into understanding the various data types, variables, and operators. Next is control structures and functions, conditional statements, logic and loops, for, while, break, pass, understanding what ranges are. Then defining and using functions and algorithms and nesting functions. Then we move into data handling, which is going to include different types of data like lists, tuples, dictionaries, and sets, and how they can interact with one another, and file operation basics and system handling. Then introducing yourself to pandas for data analysis and spreadsheet manipulation. Next, you'll move into numerical computation and some engineering libraries. NumPy is a great one to start with for numerical and scientific computation, and SciPy for a little bit of added functionality on top of NumPy. You can do different types of optimization and design checks with SciPy that are difficult with other libraries. Data visualization, Matplotlib or Plotly for creating static, animated and interactive visualizations. There are many more visualization libraries, and one of my favorites is Seaborn for statistical data visualization. This much is going to get you pretty far, and once you feel comfortable with all of these topics, it's time to start moving towards intermediate Python development concepts. And this is going to include stuff like Git and version control, aspects of object-oriented programming, building local apps, web apps, or interactive dashboards with graphical user interfaces. There are so many different tools available now that abstract a lot of the heavy lifting away from this type of thing, and they're really easy to use and give you a lot of flexibility in what you can do. You learn how to connect services with APIs and data streams. You learn how to manage errors and exceptions, debug your code and test your code, some performance optimization aspects, how you can improve your code, and then move into more advanced Python programming principles. The language is incredibly deep. There are careers worth of knowledge to be gained through learning about Python. And then finally, interfacing with engineering software, which is a very popular topic that people ask me about a lot, and that's about communicating and controlling commercial engineering tools using component object models and API protocols, which allow you to control AutoCAD or Revit or some structural analysis softwares like SAP 2000, ETAPS, or ANSYS with Python. So once you get this far, you're well on your way to paving your own path and exploring avenues of personal interest and relevance to your own role or career aspirations. And we can cover these more advanced discussions in future videos. I believe that you can learn anything you want by yourself, provided that you're stubborn enough. That's how I did it. And while I don't regret it, there's a much better way. Flocode's courses are designed to teach you all of this material and more in an engineering context using engineering examples, which makes learning this stuff a lot easier. So if you want to learn efficiently, go to flocode.dev. But if you would rather dive into this stuff on your own terms, I completely understand, because that's what I did. Although it did take me many more years than it needed to. Either way, I wish you the very best of luck. Just remember that it's a marathon and not a sprint. So that's the roadmap. Now I want to run through the Flocode curriculum. We're just going to be skimming the surface here because there's so much to discuss, but I think this will help give you some perspective on the path ahead and how Flocode approaches the subject of adopting Python for professional engineering. So first up is this course where we introduce Python and its significance to our profession. Hopefully by now you have a broad understanding of Python's potential in engineering and that it's really worth digging deeper into programming. But up next is the Python for Engineers Essentials course, and this is where we're going to establish a strong foundation in Python programming and focus on core concepts and their application in solving simple but commonplace and relevant engineering problems. Then we move towards the intermediate course where we're going to bridge the gap between fundamental Python programming and a more practical application in standard engineering tasks. So we'll cover some object-oriented programming, error handling, and more advanced data structures, along with a lot more. Then we start moving into the more advanced topics. The advanced course is going to explore some more sophisticated engineering challenges and systems and how Python addresses them. We'll include simulations, optimization, tool integration, and creating some custom Python tools. Then the final two courses, the first of which is the expert course, which is going to push forward with some new ideas, data engineering, machine learning, and some more advanced simulations that will enable you to develop your own custom Python applications and workflows for your specific engineering problems. And the specializations module are going to be tailored towards specific learning paths for engineering disciplines that address unique challenges and opportunities within each field. So next steps, I encourage all engineers to embrace Python, and whether you're looking to streamline your own workflow or to figure out how to do things in new and different ways, or just to simply expand your skill set, Python offers a world of opportunities, and it's more than just learning a new skill. You are going to be equipping yourself with a tool that can significantly enhance your engineering capabilities and reach, and just open you up to new ways to find solutions. You will be amazed at the utility of Python for areas of personal interest outside of engineering. For me, that included finance, web development, automation, music production, and a whole bunch of other things that you might be interested in. So looking ahead, the Flocode courses will continue to work on unraveling the potential of Python in engineering. We're going to dive deeper into specific applications and cover many areas of focus in civil and structural engineering from the ground up. So for those that are eager to continue this learning journey, head over to flocode.dev. You can find what you need there. And additionally, to stay updated on the latest trends, insights, materials, and everything else that we're building here at Flocode, make sure that you're subscribed to the newsletter. The link is down below. The newsletter is an excellent way to keep in touch with the community and discover new applications of Python in engineering and get regular updates on how the Flocode project is progressing. Thank you very much for your time and attention throughout this course. I deeply appreciate it. And keep innovating. I look forward to seeing you inside the Flocode community. All the best. Bye bye.